A cation is an atom with a positive charge. It is created by a loss of valence electrons. So far we've been talking about that our atoms are neutral. The protons and electrons are equal. So a cation is formed when we have a loss of valence electrons, making more protons than electrons and giving it a positive charge. An anion is an atom with a negative charge. It is created by a gain of valence electrons. So again, our protons and electrons are neutral. When we gain electrons, we're going to have more negative charges and then positive charges, giving it an overall negative charge. Our atoms gain and lose electrons in order to have a full octet of 8 valence electrons. And so they get these charges. So cation and anion. A cation, you take the positive sign and you make a little cat out of it. Positive cat, positive. Anion, an ant, is long and skinny, like the negative sign. Loss of electrons is oxidation. Gain of electrons is reduction. So a way to remember this is Leo, the lion, goes grr. Leo, loss of electrons, oxidation, grr, gain of electrons, reduction. The octet rule, we've already discussed this, but atoms react by gaining or losing electrons to acquire the stable electron structure of a noble gas, and this is usually 8 valence electrons. An atom is unstable when the valence electron shell is not full, and so an unstable atom will react with other atoms, becoming an ion when we have changes to the electrons to get more stable. Noble gases usually have a full octet of 8 valence electrons, with the exception of helium that only has 2 valence electrons. All of our noble gases are very stable. They do not react with other elements. We've said that they are unreactive gases. So here we have neon in the center, and aluminum, magnesium, and sodium, they're all giving up their electrons. Oxygen, nitrogen, and fluorine, they're all taking their electrons, and neon's like, oh, you're all just a bunch of wannabes, because they want to be like her. They want to have that full octet of 8 valence electrons. So take out your periodic table. We have previously labeled on our periodic table the group numbers, but I just want to show you. If we were trying to find the electron configuration for boron, we're going to start at hydrogen, 1s2, 2s2, and then 2p1. Our highest energy level is the second energy level. The valence electrons are in the highest energy level, S and P. So we have 2 in the 2s and 1 in the 2p, having a total of 3 valence electrons. So we labeled the A group numbers on our periodic table previously, and if you don't have this, you're going to want to go ahead and label it. But that tells us the number of valence electrons. So I kind of showed you the shortcut to start with. But boron has 3 valence electrons, and we can see 2 of them are in the S sublevel and 1 is in the P sublevel. So with these numbers of valence electrons, we can also determine what the charge of the ions are going to be. When we have 1 valence electron, we're going to lose that valence electron to look like our noble gases. So it's going to have a 1 plus charge. Our 2A column is going to lose 2 valence electrons, so it's going to have a 2 plus. Boron would be 3 plus. Our 4A group, they can either gain or lose, so we're not going to write anything right now for them. We'll talk more about those later on. 5A, we're going to gain 3 electrons to get to 8, giving it a 3 minus charge. Oxygen's group is going to gain 2 for a 2 minus charge, and then our halogens are going to gain 1 for a 1 minus charge. So you have this chart. We're going to look at potassium. Potassium has one valence electron because it's in the 1A column. It is going to lose one valence electron. Please write lose, don't write -1. This is to try to help you not get confused. When we lose one valence electron, we're going to become positive and be a cation. The oxidation number is the same as the charge. So this is going to give us a 1+ charge. The ion symbol is the symbol of our element with the charge. You can write 1+, but you can also just write plus. For bromine, it has 7 valence electrons. It is going to gain 1 electron. When we gain 1 electron, we're going to have a negative charge, which makes it an anion. And this is going to give it a 1- charge. The symbol for bromine is going to be Br-. For phosphorus, it has 5 valence electrons. It is going to gain 3, giving it a negative charge, so an anion, and a 3- charge. So the symbol, the ion symbol for phosphorus, is going to be P. We need that 3 in there now because it's more than just 1. Gallium has 3 valence electrons. It is going to lose 3, giving it a positive charge, a cation. This is going to give it a 3+ charge. And so now our ion symbol is going to be Ga3+. So that's all you need to know right now about forming ions. We'll talk more specifically about our transition metals and intertransition metals later on. But right now, this is all you need to know. A bond is defined as a force that holds groups of 2 or more atoms together in a compound. This usually consists of 2 electrons. All bonding has to do with the atom's electrons and how those electrons are being used. So electrons can be used by either being transferred, shared unequally and equally, or they can be loose between atoms. We have 3 types of bonds: ionic, covalent, and metallic. We're going to focus on ionic and covalent bonds in this course. An ionic bond ionic bonding occurs when electrons are transferred between atoms. The metals react with nonmetals to form ionic compounds. We said that our metals are typically going to lose electrons, giving them a positive charge, a cation. Non-metal atoms are going to gain electrons, making them negative anions. The bond that holds these oppositely charged particles, oppositely charged ions together, is called an ionic bond. So covalent bonds electrons are shared between 2 atoms. The nonmetals react with other nonmetals, or they can also react with metalloids. They form a covalent compound. We have 2 types of covalent bonds, though. Covalent bonds that are nonpolar occurs when the electrons are shared equally between the 2 atoms. So here's the 2 nuclei of the 2 atoms. Those electrons are in the center, equidistance between the nuclei. They're shared equally. Polar covalent bonds occurs when electrons are shared unequally between the 2 atoms. So these are the electron clouds, and we can see that the electrons are more concentrated towards fluorine than they are towards hydrogen, giving us a partially positive and a partially negative end of the atom. Those are going to create 2 poles and give us a polar covalent bond. We'll talk more about polarity towards the end of this unit. I'm going to show you this demonstration for ionic and covalent bonding. So sodium has 1 valence electron, chlorine has 7. They're not stable because they don't have 8 valence electrons. Sodium is going to lose its 1 valence electron, giving it a positive charge. Chlorine is going to gain that electron, giving it a negative charge. We have an electron transfer going on and a formation of ions. This formation is a formation of an ionic bond. So now if we look at chlorine, still has 7 valence electrons, but Cl2, they're going to come together and they are going to share these 2 electrons, forming a molecule known as a covalent bond. Metallic bonds, that's our third type of bonds. Metallic bonds are forces of attraction between free-floating valence electrons and positively charged metal ions. Metallic bonds occur when you have a group of metal atoms closely packed together. They form positive ions, and then their electrons are loosely held, and it's kind of like a sea of electrons, or I like to think about it like the jelly that kind of holds those metal cations together. So the difference between a metallic bond and an ionic bond. Here, the red dots are metal cations. The yellow dots are free-floating valence electrons holding them together. In an ionic bond, the red dots still are our metal ions, and then the blue or grayish dots here are the non-metal atoms. So we have 2 atoms here, opposite charges holding together. Here we have 1 type of atom, positively charged, and then electrons holding it together. So a little summary, a visual of those different types of bonds. So if bones are electrons and the dogs are atoms, metallic bonding, we have a group of dogs and the bones are being shared among them. They're kind of floating among them. So atoms closely together, the electrons are floating among them. Covalent bonding, the dogs are all sharing one big bone. So covalent bonding in atoms, the atoms are sharing the electrons between the atoms. Ionic bonding. We have the small dog, the little puppy, and the big dog stole its bone. The little dog lost its bone, the big dog gained it. The metal atom, the cation, lost its electron. The non-metal anion gained it. We had a transfer of electrons, transfer of bones between those. So just to review different types of bonds, we're going to look at these formulas and determine, is the first element a metal or a non-metal? So titanium, the first element is a metal. Oxygen is a non-metal. A metal and a non-metal together forms an ionic bond. Carbon is a non-metal, and hydrogen is also a non-metal. This forms a covalent bond. Still, carbon is a non-metal. Sulfur is also a non-metal, so it still forms a covalent bond. I want you to try these last 2 on your own. Go ahead and pause the video and then come back and check them. Welcome back. Potassium is a metal. Chlorine is a non-metal. This is going to form an ionic bond. Hydrogen is a non-metal. We have 2 atoms of hydrogen, so they're both non-metals, giving it covalent. And then one other example that I wanted to add in, SiO2. Silicone is a metalloid. Oxygen is a non-metal. This is going to still form a covalent bond. A metallic bond would be 2 metals bonded together. You have practice after this section of notes. Go ahead and finish that up. and stop by and ask me if you have any questions. Thanks. Have a great day.